Well, hello again. Welcome back. So this is the third of the wave behaviors that we're focusing on. So we've done interference with the first two videos. And then I did reflection, kind of a lengthy one because there's lots of different ways waves can reflect. This one I think will be a little shorter. It's a behavior known as diffraction. Now watch out for these names. They're all very similar: reflection, diffraction. The next one will be on refraction. So make sure you're keeping the name straight. But like all the other ones, I'm going to show you what this wave behavior looks like with my little virtual ripple tank. You'll get a chance, hopefully in class, to see it yourself, because this is one that's pretty easy to see. And I find it very kind of curious and interesting that waves do this. So let's just go right to the ripple tank. And I'll show you what I got set up here. So I put a wall in the middle of the tank, and I've got these plane waves that are coming down like this. All right. So I want you to imagine for a second that you're trying to hide from these waves. You don't want to be hit by the waves. If I asked you, like, where would you hide from the waves so you wouldn't get hit by them? You know, maybe these are big water waves and you're trying not to get hit. You might think, well, I'll hide behind the wall. The wave can't hit me there. Because as we've seen before with a wall, the wave should reflect off of here, and then off to the side where I'm showing you here, the waves should continue just straight on. And we should have this big sort of empty spot behind the wall. Well, it turns out for waves, things don't work quite that way. That would work that way if it were particles. Like if you were being pelted with tennis balls, you could hide behind a wall. But watch what happens when the waves around the wall. You see right here, this is the part that I anticipated would be like an empty area. But we definitely see waves there. Look again. If you notice, the ones that go here near the side of the wall actually bend and go behind the wall and end up filling in that space. Now, they're not nearly as strong. That's why it's kind of fuzzy here. But that characteristic of the waves, where it will turn around and kind of bend around a barrier that way, is known as diffraction. Okay, let's go back to our page here. Put a little definition down here. And again, we'll keep the definition kind of simple. This is waves bending around a barrier. Now, as I said, if you wanted to hide from somebody pelting you with tennis balls, of course you could do that. Sorry, I lost my focus here. But waves will do something that particles won't do. So particles cannot diffract that way. It would be wild, wouldn't it, if you threw a tennis ball at somebody, it went around a wall where they were hiding and it just bent and turned and went and hit them? Like, there's no way that would ever happen. So we don't see a lot of this in real life. I'm not going to give you real life examples. I don't know that it's going to be all that helpful, but I do want you to know how to draw it or recognize it on a sketch, okay? So again, this is just a picture of what we were doing on the simulation. So here's the wall. Here's the waves coming down. Now we still see reflection. I'm not going to draw the reflection, and we still see the waves continuing forward like this off to the side. But what you also saw was it bent and they moved kind of towards each other, a little bit of left-right motion, right? Now, again, when waves overlap like this, that's what we call interference. And so that pattern looked kind of interesting, the interference pattern. Something similar happens if we have another wall in place. So I'm going to add a second wall here. I'm going to move these so they're kind of next to each other. But I'm going to keep an opening in the wall. Okay? There we go. So I want you to pay attention to what's going on the other side of the wall when these plane waves hit right here at this opening. You see? And it's also happening on the end. See how they make this circular wave pattern? Okay? So we can draw that on our page like this. It's almost a clever way to turn straight waves into circular waves. Again, no hiding from these waves behind the wall like that. Okay? All right. So like I said, keeping this one to just over 5 minutes. And if you can kind of sketch those, again, this is something you'll be able to see for yourself in our real ripple tank in the class. But for now, just recognizing it, being able to describe what diffraction is would be sufficient. All right, thanks for watching.